So today I can find the mean, median, mode, and range for data sets. And if we need a decimal, we'll get it. But now that we can use calculators, which is exciting for me because I love them, then I will use a calculator. Great. But again, I'll show the work. I'll show as much work as we need to in order to get to our answers. But again, if the calculator gives us a decimal, we can write the decimal. If it gives us a fraction, we can turn that into a decimal. But these calculators that I like, they will actually turn a decimal to a fraction as well. So that's what I like about these calculators. It's the N over D button for mine. Mean, median, mode, and range. And in fact, there's this extra one down here for us. It's an outlier. So a mean, you probably have heard of the mean. It's more commonly known as an average. Okay, and then when I think of median, I think of the middle. Now, the problem with a median is that sometimes there's two numbers in the middle, okay? Now, I'm going to go into more detail on these in a second, but when I see mode, I think of most. And this isn't just me being a math nerd. This is like mode kind of sounds like most. Median, I think of like a road. In the middle, you have the median because it's in the middle. And then range is the biggest minus the smallest number in the list. So what they're going to do is they're going to give us lists of values. It doesn't matter what it is. It could be cups, it could be pounds, it could be people, it could be whatever it needs to be, okay? And they'll tell us what it is, or sometimes they'll just say, here's a list of numbers. Now find these values. The last one right there, an outlier, okay? So an outlier means that it doesn't really fit with the values that we see. So like if I see some values like, I don't know, a 1, a 2, a 3, a 5, and a 7, and let's even say 10. If this is my list of numbers, I can see that these numbers, I mean, whether you want to consider these high or low is one thing, but if we tacked on another number here and it was like 5,786,215, okay, now that's kind of weird. Like, where did that 5,786,215 come from? This would be considered an outlier because it doesn't really fit in with the rest of the numbers. Now, there's lots of reasons why that can happen. And just the fact that these exist sometimes it kind of goes to show that when people measure these or use these types of measurements, these are called measures of center, these first three, they can be manipulated. Okay. For example, let's say that we had this list right here, and let's say that I had these numbers right here from something, and I wanted to manipulate it because statistics is, it usually isn't used by very nice people. It's usually people that want to take your money from you. So if they wanted to make the numbers seem higher, they'd be like, you know what, these numbers, they're either outliers or they're just insignificant, or they'd say, I didn't need those numbers. And they could just leave them out completely. So I guess my point with this, what I'm showing you right here, is not just the outlier thing, because sometimes what will happen is they'll say, look at this right here. The 20 is an outlier because it's so far away from 10, but all the other numbers are like 3 or 1 away from each other. So they would just say, we don't want to look at the 20, even though it's part of the set. So my main point is, if you can understand these, hopefully you're less likely to be manipulated. But the truth is that anyone that uses these types of values is doing it for the express purpose of making you believe something that they want you to believe. So the moment you see it, really the data doesn't matter at that point. This is how math is used to control people. And I can tell you from being a math nerd, it is very easy to control people with numbers, because most people look at numbers and they're like, I don't care where that came from, but I can make numbers look higher than they are, and I can make them look lower than they are, or I can make them look more in the middle if I need to. Because I'm not that kind of scumbag, But there are lots of scumbags out there that are like, I need you to believe this thing. Okay? So we're going to see some of this. The mean is the average. So it says you take the sum of the numbers. That's not a hashtag symbol for my generation. That was a number symbol. And so you take the sum. That means the sum, if we go back, that means we're going to add all the values together. And then we divide it by however many numbers there are. So if this was my list, my example list, you'd add all 5 of these together, which appears to be 27. And then you divide it by however many numbers there are, 5. Now again, I'm not going to do this by hand anymore. No more stacking, no more long division. It's calculator time, okay? The median, when we say it's the middle, this list was already in order from least to greatest. If it does not come in order from least to greatest, you have to put it in order from least to greatest in order to find the middle. Because if these are mixed up and 10 was right in the middle, then you'd say, well, 10 is in the middle. But it's not in order from least to greatest. So you need to ensure that these lists are in order from least to greatest. And then the mode is the number that occurs the most. So if we went back and we had these other 2 ones right here, well, then you have ones that occur the most. These 2 ones here would be the mode. And it is possible for this to happen. Maybe there's 2 modes. Okay, so right here would say, not only is the mode 1, but the mode is also 10. You'd have 2 separate modes, which I believe on the assignment, when that happens, you just separate them with a comma, you put a 1 and then a 10. The range, and since we'll be finding the median, which we need the order from least to greatest, you just take the big number, the biggest number in the list, and subtract the smallest number. So the range of this one is 10 minus 1 is 9. Okay? And again, this particular list that we had and had started with, it has no outliers the way that it is. But if you added some very large number, or even something that was very negative way down here, then you say that's an outlier, okay? Let's just do this in order, okay? Mean, median, mode, and range. So let's start with the mean first. Now again, if you need to say average instead of mean, do it. It's not gonna matter to me. I suppose there's some math nerds out there that would freak out about it. But either way, which, by the way, I don't know if this is where the origin of mean comes from. Like, hey, you're being mean. It's kind of like calling someone average. And some people, I think back in the day, if you called someone average, it'd be like, oh, well, you wanted to fight? Okay, let's fight then. You know what I'm saying? Nowadays, it's like, oh, that's cool. Whatever. All right, so the mean, I'm going to take these 3 numbers. So I got 31. Oh, these are already in order, by the way. 32, 34. They're not in order, dang it. That 27 threw me off there. Okay, I don't need them to be in order to find the mean, right? The mean is where we're going to take all 4 of these numbers, we're going to add them together, and then we're going to divide it by however many numbers there are. I'm showing my division with fraction line. Do you have to? You do not. I don't care which way you do it. But here's what you do not want to do, is you would not want to type this into the calculator with these numbers, and then at the very end, say I'm going to divide this by 4 with one function. Okay, so you would not want to type this line in, because what it's going to do, it's going to do the order of operations where it's going to divide these 2, 27 divided by 4, and then it will finally add those other 3 numbers. So if you want to write it out in one line, what you can do, you just need to put this in parentheses. That's all. Now again, this is just if you're solving it on your own, since we are not. Here's again, this is kind of what we would want you to do if this was an exam or some kind of quiz or something, okay? So we would still want to type this into the calculator, which I will now do because I do not want to stack and add anymore. I want to just punch in buttons. 31 plus 32 plus 34 plus 27. On my calculator, I push enter, and that says, okay, that is going to be 124. Okay, so my first number, or my numerator, I'm writing it as a fraction. You do not have to write it as a fraction, but I got 124, and now I need to divide that by 4. Well, thank goodness, I can still use a calculator for that, whether I type it in as a fraction, or if I just type it in as divide by 4 and enter. It doesn't matter. I still get 31. And that right there is the mean. Okay, so if that is the mean, let's go ahead and find the mode. All right, the mode is the one that occurs the most. Now these four numbers all appear differently. They're all four different numbers, and they only appear once. So for this one, I'm just going to say there is no mode. There is none. DNE. Now some students would be like, yeah, but they all appear the most. Okay, that's more, it's just more writing than I want to do, so I'm not going to do that. Plus, on the assignment, I don't think it will let you. So I did not mean to skip the median. But here we are. Let's take the median then. Okay, the median is the number that's right in the middle. Now again, the list needs to be in order from least to greatest. So I'm going to do the work here on the right, and I'm going to list these in order from least to greatest. I'd have the 27, that's the smallest, then 31, then 32, and then 34. So if this is the way that I find the middle, even though this is a small list, this is how I would usually do it, especially if it was a big list. So I would kind of cross out the outside values, the one on the smallest one and the biggest one. I would cross these out, and then I would keep doing this if the list was bigger until I found the middle. Now here, just with doing that part, we have found the middle. It's these two numbers. These two numbers are right in the middle. If there was only one number in the middle, I would say I have found my median. But I found two numbers in the middle. So if you find that there's two numbers in the middle, you've got to take those two numbers, in this case 31 and 32, and you need to find the mean of those, which means you're going to add those two together and then divide it by 2. You should only ever have two numbers in the middle. So if you have two numbers in the middle for your median, you should always be dividing by 2. You should never have to divide by 3 or 4. You should only have the two numbers in the middle. Once again, I'm just going to put this in the calculator. So 31 plus 32 is going to be 63. And then I do 63 divided by 2, which should be 31.5. And that right there is the median. Now the last thing I'm going to point out is 31.5 is right in the middle of these two numbers, 31.5. Okay, so you can see that there's just one unit between these two. If you went a half unit, then it would have cut those two in half. And that's another way to look at this. And again, that's not necessarily doing all the work there. And yeah, once the numbers get kind of bigger or farther apart, you know, it may be not as easy to see as that, but that may not be as easy to see for some people anyways. Okay, the range is where we take the biggest number, which we have seen already. It says 34. So I take the biggest number, 34, and then I subtract the smallest number, which is 27. So when I subtract these, which I can put in the calculator, I get the range. It's a range of 7. Okay, now the mean, median, and mode, which was the first three values that we found, even though there is no mode, those are what we call measures of center. We're trying to find somewhere that represents the data, but in the middle. The range tells us how far apart they're spread. Okay, another way to say it is spread. But it also tells us how condensed the numbers are. Okay, so these are 7 apart. Is that condensed? For me, I would say it depends on how many numbers there are and what the numbers are. 27 to 34, I would say, I don't know.
So you always subtract?
And this again is where it becomes highly manipulative, because it's like these are all 7 apart. So some people would say they are quite condensed. Some people say they are condensed. Some say they're very condensed. Some would even say that that's 7, but they're 7 apart in this particular case means that they're still very spread apart. Again, the interpretation here, I think is kind of up to you. Yeah. If the number's low, then you say they're condensed. If the number's high, again, but where? Where does it split? I don't know. I don't think there's probably a formal way to do that. I just don't know what it is. Okay, so find the mean, median, mode, and range for these basketball scores. We got 90, 78, 72, 84, 66, and 90. Take a minute, see if you can find these, and then we'll go over it. Let's see how we did then. So the mean, right, we're just going to take all 6 of these numbers and add them. Okay, so, yep, when we add these together, again, just in the calculator, boom, 480. Now, of course, we're going to divide this all by 6, right, so because there's 6 numbers. So we're going to divide this by 6, and I got 80. 80 exact on that. So, at 80 is the mean. All right, next we want the median. So I need to put these in order from least to greatest. So the least is 66. Then looks like 72, 78, 84. Then we have 2 90s. That's a 0. All right, so again, I'm going to do this. I'll take the outsides, the 66 and 90, first 90 there. And I'd say those kind of undo each other. And then we got the 72 and the other 90.
We put 2 90s in.
Now that leaves me, just like the last problem, leaves me with 2 numbers right in the middle, 78 and 84. Now again, if you know that those are 6 apart and then you just cut that in half, you can do that. But I'm going to go back to kind of the old-fashioned way. We're going to take these 2 numbers, 78 and 84, and we would add these together. Again, we're looking for the average of the 2, which is going to tell us where right in the middle is. And then we'll put that in the calculator. So that's going to be 162 divided by 2, which appears to be, yep, so the median here, 81. Now again, that's 3 up from 78, right? We're looking for right in the middle there, and it's 3 down from 84, 81. Okay? So there's our median. This one does have a mode, right? We got the most number, which is going to be the 90. There's 2 90s, and there's only 1 of each of the 66, 72, 78, and 84. So we do have a mode on this one. I'll circle that. Now, before we do the range, again, look at the mean, median, and mode. These are measures of center. So, in other words, we're saying either 80 could be the center, 81 could be the center, or 90 is the center. And again, depending on what you want to communicate to people, would determine which one you want to use. And again, I'm saying communicate to people, even though a lot of people do this for manipulation purposes. Because if I wanted to be manipulative here and be like, look at the middle of this set of data and it's 90 because I use the mode, right? That's pretty jacked up because 90 is also the maximum. So is 90 in the middle? I mean, you could say this one is, but again, that becomes, in my opinion, that becomes very manipulative. Okay, so the range or the spread, we're going to take the biggest number, which is the mode for us, and we're going to subtract the smallest number, which is the 66. And yep, we're going to go ahead and subtract these. I guess I'll use orange here. 24. So again, that's just something you put in the calculator. Now again, the 24 is the spread. I think I used the wrong word on that last problem. I said condensed, but it's on the assignment it says consistent. How consistent are these values? Again, in my opinion, they wouldn't be very consistent. 24 is kind of far apart for these numbers. In addition to that, the numbers aren't really consistently very close to each other, right? Like you start with the 66, then the 72, a 78, and then an 84 kind of thing. It's like they're going up, but they're kind of going up big. But again, you could manipulatively say, well, they're not going up very much, so it is very condensed, or not condensed, consistent. There we go. Let's do the mean, median, mode, and range for this one. You guys try it out. Try this one out too, then we'll go over it. Okay, well, let's take these 5 numbers and we're going to add them together. 262 plus 265 plus 272 plus 272 plus 287. Now again, this is just a calculator thing. We don't need to stack and add these. You just put it in the calculator and find that sum, which when I put it in my calculator, I got 1,358. Now, it is a mean or an average, which means we're going to take all 5 of these and divide it by the number of numbers, which is 5. So, in my calculator, 1,358 divided by 5, and I got 271 and 6/10.
Yep, that's what I got.
Boom. Well, that is the mean. That's it. Okay, this list actually came already in order from least to greatest. So if we were to look at this list, we would want to find the middle number. So again, I would look at the outsides, kind of cross those out together, and then the next numbers towards the middle, and we see the number right in the middle is just this 272. So the median is 272. Now, the list is in order from least to greatest. We have 272s, so the mode is also 272. Now again, just if we were to compare these centers, they're pretty close together. So you could say maybe that means that the information is more legitimate if you, no matter which measure of center you use, you get to decide. But again, it can still be highly manipulative. The range here, we're going to take the biggest number, which is the 287, and we'll subtract the smallest number, which is 262. Again, just put that in the calculator, boom, 25. Okay, so the range, which is telling us how consistent it is, 25, is that consistent? For these large numbers, you could say maybe, but again, you'll have to decide. Okay, 2 classes were given identical quizzes. Class A had a mean score of 8 and a range of 7.9. Class B had a mean score of 8.4 and a range of 5.3. Okay, so we're going to write a statement comparing the means. All right, so the means for Class A, they have a mean score of 8. Class B is 8.4. Now, of course, there's lots of different ways to compare this. This is the way it's going to sound on the assignment. I'm not saying it's going to be exactly this, but we'll say on this one, Class B has had a higher mean, which I'll say, or average, score on the quiz. Boom. In fact, you could say than Class A, if you want to be a little bit more specific there, okay? Yeah, Class B is higher, 8.4 is bigger than 8, or 8.0, okay? All right, the consistency statement. So Class B has a lower range than Class A. So in addition to this, we would say that Class B is more consistent than Class A. Now, if I wanted to be a little bit more accurate with my wording, I'd probably say it appears that Class B is more consistent than Class A, because we don't really have a ton of information here, or like we don't know how many students took this quiz in either class, and we don't know what the scores were exactly. So this statement that I have as is, in my opinion, is actually quite manipulative, which is the danger of these types of statistics. We got a small business that has 6 employees. It includes the owner. Okay, so we got these salaries: $28,000, $30,000, $32,000, $65,000, $72,000, and $380,000. From this data, we know the following. So we don't have to find this, but we assume that they've done the work for us. The mean salary is $121,400. The median is $48,500. Of course, there's no mode because none of them repeat. And then the range is $352,000. Okay, so if LinkedIn, or what is that, rights reserved or something, pulled the data and reported out only one number to describe employee salaries, would they generally use a measure of central tendency or the range to describe the business? Okay, so I've never seen where people use a range or a spread, right, where they'd say, look at the range of salaries, it's $352,000. It's kind of weird. They'd use one of these 3 numbers, even though, there's no mode right there. So generally speaking, when we look to describe numbers, we we usually use some form of the central tendency. Now again, which one would be used? That's up to whoever's doing this to decide, which is also the scary part. Because just looking at this, so it says which measure would be the most representative of the company's employee salary. So we know central tendency, so again, we're not using range here. But you have two really to choose from because there's no mode. You got either a mean or you got a median. On the assignment, they want you to say that it's the median because, if I can spell it, the median would be the one you'd want to choose because it's more representative of the values. And in this case, we assume this is the owner, $380,000. That would be considered an outlier because it's so far away from the next lowest value, which would be the $72,000. So it's an outlier, and then if you think about that, then you take out that number, and then you use these 5 in order to either find the mean, median, maybe even the range. Okay, jewelry store wants to make sure they have the most common ring size for women in stock. So we got all 4 to choose from: mean, median, mode, and range. And again, I didn't write this question, but the key word here is most. So which measure should we use? Mode. Mode is correct because mode is the most. So if of course you're making ring sizes for women and you've made a ton of these size 8 rings, I don't know what that is or if that's common. I don't care either. But if you saw that it was size 8, then you'd want to have those in stock because it's the most common one that women seem to buy in your jewelry store. Boom, that's it. And that is our objectives, all objectives. I can find the mean, median, mode, and range. And hopefully now that we can do that, now when we see that people give us some kind of mean, median, mode, and range, hopefully we are less likely to be controlled by that information.